Hello, my name is Jason Huggins and today we're going to look at network security in Uniface, particularly secure network communication. Let's start by looking at the challenges we are presented when looking at security in IT. Security attacks are on the increase, whether we are looking at cyber attacks, ransomware, or data breaches to name but a few. Data breaches tend to be the things that cause a lot of the damage because information is being leaked and misused. Let's look at the consequences of these security challenges. If we take ransomware, for example, this could mean that your business data is locked away and inaccessible to you. Naturally, this will cause significant disruption to your businesses. If personal data is stolen, this can lead to identity theft and the associated consequences of that. Given the privacy law across many regions, if personal data is stolen, this could mean that your business faces significant fines. Finally, data is key to many businesses. For a software company, for example, the data could be your source code, i.e. your intellectual property. So this is the thing that potentially gives your business the cutting edge. If that gets stolen, that is naturally a problem to your business. Overall, all of these breaches and many more will lead to significant financial consequences for your businesses. So, what is the cause of these problems and why are we seeing a continual increase in the breaches? Well, part of it comes down to the network. Typically, we use TCP/IP as a network communication protocol. This has been around for many years and has served the purpose well. However, there is a fundamental flaw. It is based on the OSI 7-layer model. It's a very resilient model, automatically rerouting if there's problems in one part of the network. There is, however, a fundamental flaw in that none of the layers explicitly deal with security. If a cyber criminal, for example, does a man-in-the-middle attack to listen to the data and potentially modify it, this model does not account for that. There are a number of solutions to the problem. However, the main one we will look at today is TLS, so Transport Layer Security. By implementing TLS and adding it to the network stack, we are adding a cryptography layer to the communication protocol. In summary, cryptography is essential for all apps. What we will see in the coming slides is that this is easy to implement in Uniface. TCP is used in Uniface for the communication between processes. So if we have a client process, such as the Uniface runtime, talking to a back-end application server, it will talk using TCP/IP. This is the protocol used between all of the different processes with Uniface, as well as external systems, for example a mail server or an LDAP server. Because these all go over TCP/IP, this is a potential security flaw. How have we solved this? We've added the cryptography layer as described earlier by adding TLS to the network stack. We have implemented TLS by utilizing the industry standard toolkit OpenSSL. This is often considered the Swiss Army knife of cryptography. It is backed by major organizations and is highly secure and well proven. By utilizing it in Uniface, we are able to take our plain text communication and encrypt and decrypt the message during transit. The encrypted message cannot be deciphered by an attacker. There are two main configuration options when configuring TLS in Uniface. The first is pre-shared key. With a pre-shared key, the same key is used to encrypt and decrypt the message. By definition, this mechanism can be weak. If that pre-shared key is leaked, an attacker can both intercept and decrypt the messages, as well as impersonate genuine messages. The second option is to use key pairs. In this case, different keys are used by the recipient and the sender for encrypting and decrypting the messages. The private key is kept private, therefore a cybercriminal cannot mount a successful attack. If we take a look at a typical Uniface deployment, we can see that there are many components. Each of these can be connected by a network connection, and if using TCP/IP, are vulnerable to attack. By adding the OpenSSL layer, we have secured all of these communication mechanisms, both between Uniface processes and to external processes such as LDAP and mail servers. This may sound like a complicated area and something that may be difficult to configure, however it is not. We have ensured to keep the configuration familiar and simple. If we start by looking at an unencrypted communication channel, the configuration is as follows. If we look at the client on the left, we can see that there's a TCP protocol connecting to a server on a listening port, specifying the username and password, and then the Uniface server type. On the right-hand side, we can see that the server listener is also using TCP on the same port, and then further in this configuration file, we would have the definitions for the Uniface server types. To secure this is quite simple. We'll start by looking at a pre-shared key configuration. In this case, we change the protocol to TLS. Again, we're connecting to the host and a listening port, and in this case I'm specifying a network profile which I've called PSK. Again, we have the username and password and the Uniface server type. On the right hand side, so the server, we can see that I've changed the listening protocol to TLS and also specified the network profile of PSK. The definition of this PSK network profile is straightforward, and what we can see here is that we have in the net settings section the profile name I've specified, and the parameters for this are the shared key and then that shared key value, so the secret key. As mentioned, this can be weak because that shared key could be easily leaked and used by anybody. The more secure option is to use certificate-based public-private key pairs. In this case, I've specified a network profile that I've called CERT. The configuration for this profile is also specified in the net settings section. Let's look at some of the key points in here. If we look at the left side, we can see that I have the CA certificate. The certificate authority is the provider of your certificates containing your public and private keys. This is required by the client to verify that the certificates it receives from the server are genuine. The next setting on the client side is a cipher list. These determine the type of encryption that will be applied. There are different ciphers, and these give different levels of security and performance. On the server side, we have the server certificate that is passed to the client for the client to verify the server, again using the certificate authority. The server key is used for the server to encrypt its data, and this is the private key. And we can also see we have the matching certificate authority and cipher list. The keys that you use will typically be generated by a certificate authority. There are many out there. However, it is also possible to use your own in-house certificate authority. Once implemented, your system will be more secure. You won't explicitly notice much difference, however, I'll illustrate to you what changes here. If I have an unencrypted connection and look at the network traffic, we'll see the following. We can see that the communication protocol is TCP, and the data captured reveals information. If I switch to TLS, we can see that the protocol is now TLS 1.2, and the data reveals nothing of consequence because it is encrypted. There are a few things to consider when utilizing TLS. From a developer's perspective, there is practically no change. It may, however, be necessary to consider things such as transaction size and the split of processing between the client and the server. This is because TLS, or encryption, adds an overhead because there is more work happening in doing that encryption. Some of the considerations are similar to batch processing. For example, do you process everything in one big batch, or do you split it into smaller chunks? From an operations point of view, there is more to consider. It is necessary to understand security and TLS. I mentioned the different ciphers that are available, so the right choice has to be made relative to your organization's policies. Resources such as OWASP help greatly in this area. It details recommended ciphers and any flaws that have been found in others. It also promotes general good security practice. As you've seen in the configuration files, there is potentially sensitive information, such as the location of the key files. For this reason, it is important to make sure you use the Path Scrambler. As part of our security initiatives, we have released a new Path Scrambler. The old Path Scrambler encoded information, while the new Path Scrambler encrypts information. This provides a much greater level of security.
In this demonstration, we'll look at some of the concepts discussed. We'll start with an unencrypted connection. We'll start by opening the client assignment file. In here, we can see we have a regular TCP connection to the server. If we now look at the uRouter assignment file, so the listener, we can see that it is listening on a TCP port. The data server connects back to the uRouter and effectively acts like a client. At this stage, it doesn't have any specific configuration. It will use the DNP, which points back to the uRouter. When we start the uRouter monitor, we can see that we are indeed using TCP. When we start Uniface, we will see that it connects to the uRouter using TCP, and also the uServer that starts also connects with TCP. Let's now enable TLS using pre-shared keys. We'll start with the uRouter, and in here we'll change TCP to TLS. I'll use a default connection profile specified in driver settings, so I will uncomment this line I entered earlier. I'll save the file and restart the uRouter to pick up the changes. This is now listening on a TLS channel. I'll now update the client assignment file to match. I have the same pre-shared key specified in the driver settings section, so I'll uncomment this. I'll also change the connection protocol from TCP to TLS. I'll make the same change to the data server because, as I mentioned, this is effectively a client. The uRouter monitor is also a client, so I'll make the same change here. When I restart the uRouter monitor, we will see that the initial connection fails. This is because the configuration is still set to TCP. I can change this in the options under File Settings. Now when I connect, we can see that the uRouter is indeed listening using TLS. When I now start Uniface, we will see that it connects with a TLS connection, and so does the uServer. next option will use public and private keys. We'll start by reconfiguring the uRouter. I'll comment out the pre-shared key section and replace it with this second section that specifies a server's public key, the server's private key, and the issuing certificate authority. We can see those three files on my file system. First, we have the certificate authority. Next, we have the server's public key that was issued by the certificate authority. And finally, we have the server's private key, which, from a best practice point of view, I'm not going to show you the contents of. I'll now update the clients to reflect the same change. In this case, I will ask it to verify the server, and I will specify the certificate authority used to do that verification. I'll now restart the uRouter to pick up the changes. When I restart the uRouter monitor, it looks the same as before, showing that TLS is enabled. And when I start Uniface, it also connects using TLS, however, this time in a much more secure manner. Although our network configuration is now secure, our configuration files are not. We will therefore use the new path scrambler to encrypt the sensitive information. We start by enclosing the sections of text we wish to encrypt with double brackets. The start and end delimiters must appear on one line unless used in combination with the line continuation marker. You can encrypt complete lines or just parts of the line, for example, the password. You can mark any text for encryption apart from the section headings, for example, paths or settings. Once you have marked the sections you wish to encrypt, you can save the file ready for encryption. We run the path scrambler from the command line, passing in the file we wish to encrypt. This will create the encrypted file. I'll now replace the original file with the encrypted file. If we look at the file, we can see the various sections we marked are now encrypted. I'll now restart the uRouter to read the encrypted version of the file. And when I start Uniface, it loads as expected.
To recap, data breaches are on the increase and they affect everybody. It is important to make sure we secure our network infrastructure. The network tends to be one of the weakest links, and it's also important to remember that attacks can come from the outside, however they can also come from the inside. This may be malicious or it might be accidental. Someone may have a piece of malware that they don't realise, and they're therefore attacking you from within your organisation. Cryptography is therefore essential for all apps and must be applied. In Uniface, we have implemented TLS by using this industry standard OpenSSL libraries. To make sure everybody can utilise this quickly and easily, we've made sure the configuration is very simple. I've shown you one example of configuration, however there are many others. For example, we can implement client-side certificates as well as peer name verification. Security is a shared responsibility. The Uniface TLS implementation will solve one weak link. However, all relevant parties must work together to ensure end-to-end security of their IT solutions. Thank you.